this is different. Okay, wonderful. So today, my plan today is to work through the sorting examples. Okay, and I want to emphasize a lot on sorting. Sorting is something extremely important, and yes, not this one. Let me pull out. Okay.
Sandeep, before we start, can I ask a small question actually?
Yeah.
Yeah. I mean, how should I progress further with the content of the course actually? Should I just follow your classes along with the batches, or should I start wrapping up like from number 1 to number whatever 60, 70 courses are
The
listed?
sequence which is there in the course, you just go with that.
Okay.
On top of it, the exercises that we do in the class, you just do that.
Okay.
Okay.
So Sandeep, on the same lines, right? Remember in initial first few sessions, you said that you are reworking on, how this session should go on in terms of the schedule and things, right? And you said that you would share some, rough, what do you say, schedule, right? The one which we get in an email, I think it's the first one. And I think you said that you worked on it and changed it. So is it possible for you to share that? So
Yeah. So I think I need to do the recalculation. I have not worked. I completely forgot that part. So I think let's do that on Monday. I'll rework it. If you can just put it on the WhatsApp group, I'll just rework it on Monday, and then probably would streamline the rest of the things. Okay. And yeah. So I mean, there'll be more things that will be coming up, right? I want you guys to do more Gen AI projects now, just after the Python things. And so now that your Python is practically over, I'm expecting, these are the peripheral libraries like regular expressions, like, right? One is regular expressions. The other library I want to cover is OpenAI's embeddings, right? So I will cover that OpenAI's library so that, think of OpenAI instead of thinking of it like machine learning and stuff that it will come in the end. Think of it like just like, reading the data from the file. Okay. So I think we start with the OpenAI API immediately after the Python thing. So one of the chapters, regular expression, OpenAI embeddings, we'll just do the sentiment analysis. That's a pretty simple thing. And I will carry on with the maths. Maths as in we will do a bit of more detailed math, probably a bit brief about calculus. So, I mean, from the perspective of machine learning, I will do a brief gap here. Okay, because I don't want you to, get lost in that books and books of calculus. Okay, so I want to spend good quality time in this class on the math that is needed for the rest of the course. Okay, and I just don't want to teach you random maths. Okay, which has no correlation. Like, for example, integration, I'll not be teaching as part of calculus. Similarly, I'll not be teaching too much of symbolic manipulation of symbolic differentiation. I will be mostly focusing on the numeric differentiation, and I'll be focusing a bit on the symbolic in the beginning. So, and then we will, I mean, those are my upcoming topics that are there after bit of data structure algorithms. Data structure algorithms, we have covered few of them already. One is a binary search. Okay. Other is a dictionary. Dictionary we have used. Okay. And third one is what I'm going to talk about today, which is essentially the sorting algorithms. Okay. So yeah. So I think
Yeah.
I have to think a little bit more. The more I think about the entire course, the more I'm convinced. The more I'm convinced that I should spend more time on maths and data structures.
Yeah.
Okay,
Okay.
because
Yeah.
those are the parts that take the longest, and they become like entry barrier in the game. Okay, and those are the parts that differentiate one engineer from another. In all my projects, even now, I have the other projects going on, so. The problem solving is a direct function of understanding of data structures. Okay.
Yeah.
And of course, problem solving is also a function of understanding of machine learning, understanding of the other ideas like maths. Okay. But I mean, these are like the way I'm thinking of the entire class is that I want you guys to become like a problem solver so that I should not hesitate in hiring any of you in my projects. Okay.
Okay.
So that's kind of my perspective of the class. And that's why I'm myself very much focused on it, that I'll teach what what I think is needed in my projects. Okay. Not like on a superficial level that, okay, I'll just teach you this API and and that's it. But I mean, I have never been able to successfully execute a project with the people who have superficial level of understanding. Like superficial level, like those people who can just use this library to get things done, but they do not know how the library is working. So though that kind of team has always failed me. I mean, I have never been able to execute anything with them. And that's why my entire focus with this class always remains as somebody, can I can I hire these people to work with me? That's how I'm looking at it. Okay. I think of all the projects that I've done from Amazon, InMobi, my own company starting perspective, and the current project. So that's why I'm thinking that we should include the OpenAI one immediately so that you guys get more practice on. And when I talk about the OpenAI API, I'm not talking about, just calling the API. I'm talking about a bit of maths around the embeddings and other things. Okay,
Yeah.
so that is something that I'm going to spend time. So yeah, uh,
So,
that's
Sandeep,
basically the.
sorry, one quick question. So about the math part, right? You said that we won't touch integration and all that. Do we need to know that? Uh, no, right? So anything which we are not touching is not absolutely necessary to go ahead.
Correct. Like for
Okay.
example, rest of the maths is not really needed. Okay. I mean, not really needed as in, of course, it's needed in rest of the game when you are computing area of something and things like that. You need to know how to do that. But other than that, and even when it comes to computing area or computing integration, you should be able to do it. When I teach you how to do numeric differentiation, you'll be able to do the numeric integration. Okay. And so I think the good news is that the fundamentals are way more easier. Okay. And the fundamentals look difficult to those who have not been taught by the people who have thought about fundamentals. Okay. So I think fundamentals are way more easier, and you will become very much more comfortable with those things. Like you guys have become comfortable with even doing Gaussian elimination, right? Gaussian elimination is probably the hardest exercise that an interviewer can ask you. Okay. harder than the entire machine learning. Okay. And like most of the people who are like this data scientist, celebrated data scientist on LinkedIn, they can't do it. Okay. They fail that interview. Okay. So yeah. So what we are doing in the class is something so good that I'm actually pretty happy about it. Pretty happy about it. That it by the end of it, you all will have this amazing confidence. Like we spent good time on recursion, right? And most of you got the feel of the recursion. And that's that's a kind of magic I'm talking about, right? And so things that require a lot of memorization that are not worth learning. Things that require things that can be, you know, things that are superficial that are not required to be learned. Things that are fundamental, they are super easy to learn, and therefore the class has to be easy, not difficult. Okay. So I hope
Yes.
I'm making sense.
Yeah.
I'm just trying to see. I had prepared this earlier, and everybody has gone through this one, right? We talked about big O complexity. Do you want to brush up this idea? Do you want to brush up quickly?
Yes, please.
Yeah, we can talk
Okay.
about it.
Yeah, because I'll talk about a bit more about sorting. So, okay. So for n equals to 10, hello will be printed how many times?
10 times.
And for n equal to 100?
100.
Correct. And in this one, for n equals 10, how many times hello will be printed? Vaguely, just 100. And for n equal to 100?
10,000.
10,000.
Perfect. Perfect. And here?
And no.
And log n.
Log n. That's correct. So for 10,000, it'll be printed 14 times, approximately log n. Okay, because it's doubling every time. So 2 to the power something equals n, and that something is going to be log of this, right? So 2 to the power times iteration, right? Let's say t times, this thing goes t times. So after t times, I will become 2 to the power t, which is equal to n, and therefore t is going to be log of n. That's the definition of log, by the way. Okay. The definition of log is exactly this. All right. Okay. So on plus 1 is on by 2 is also on, like that. Okay. So we call this order of complexity n if there are n data size is n and it goes n times approximately, we call it order of n. If the data size is n and the loop goes for approximately n square times, we call that order of n square. If the loop goes log n times, we call it log n. Okay, we don't have to tell the base because the difference between the base is very, very insignificant. Okay, so yeah, so we just call it log n. Now the same thing is, this is a time complexity. Similarly, there's something called memory complexity. If you are adding to the memory every time, then memory complexity is also defined in the terms of order. Not precise because we don't know. We don't know how much time will it actually take. We just estimate the order of complexity, not the exact. Okay, that's why there is a big O, order of log n. All right, that's a way to write it. Order of log n. Okay. All right, so this is right. So we understood the big O notation. We practiced with arrays, strings, and loops. We talked about dictionaries. functions and recursions. The stack, queue, and list we have talked about, but we have not talked about stack and queue. I mean, we'll talk about these briefly. Tree, heap, and sorting. So where's sorting in this? I don't see sorting. Okay, sorting is somewhere. Okay, so binary search and sort. These two are, how do I reduce its size? Okay. All right, so this is briefly what is data structures in algorithm. The most important parts in this are recursion. If you can frame your logic with the normal variables, you will be able to frame recursion. Okay. Now I want to talk a little bit about sorting, right? So essentially, sorting is the core idea behind many things. Okay. If you have, like, I just want to throw this trivia to all of you. How fast can 1 gigahertz processor sort 1 terabyte data? This data is made up of 10 billion strings. Yeah. Just take a guess. Take a rough guess. Doesn't matter if you are completely off. It would take around 6 to 8 hours. There is no, there is no way to guess it. Okay. So we just need usually faster sort, bigger data for sorting, and we need to do it more often. Why we need to do more often?
How
And
did we estimate this, Sanjay?
there is no way to estimate it. You can just do a calculation that these many comparisons are going to be there, and therefore this much. But in real life, the bottleneck in this problem would be reading 1 terabyte data into the memory. Okay, there's no way to guess it. Okay, this is certain thing I have picked up from the internet. And sorting is so important that there has always been practically a war on sorting the data. In 2011, Google published the report that they were able to sort 10 petabyte data in 6.5 hours using 8,000 computers, approximately. Now, sorting is such a big deal. Sorting is a big deal because every data processing requires sorting. For example, every SQL query that you see, most of the data of the world is structured and kept, like lots of organized data in organizations kept in databases. To talk to database, you used a query language called SQL. In SQL, you basically select columns, filter the rows, just like what you do in Excel sheet. Similar thing you do in the database, but using the SQL query. The where clause, okay. When you are looking up for the data where some column value equals this, that is improved if the data is sorted. Okay, meaning indexing. Group by involves sorting. Joins are enhanced by sorting. Distinct is also impacted by sorting. Order by is impacted by sorting. So most of the systems that you see around are impacted because of sorting. They directly or indirectly use sorting algorithm. And it's very, very obvious that we will use sorting in many of the problems. Okay. And Most of the algorithms depend upon sorting. Now, okay, so most of the algorithms depend upon sorting. I'm going to skip some of the things, okay? And yes, I wanted to show you one little diagram. All right. So here is a good question for all of you. Okay. You have a plain text file containing hundreds of textbooks. Okay, say 500 megabyte. And you have to find the frequency of words. How would you go about it? Everyone?
First, we can search, right? Search for those words.
So I
Or
mean, this is a standard. Yeah, you can use a dictionary or a hash map, right? What we could do is every word you read, you create a hash map or a dictionary or with the key as a word and the value as the number of time it repeats, and just read it one time and then do it.
Perfect. Perfect. So see, one way could have been that we read one word and search for that word. That'll take forever, right? That'll be order of n square, right? Instead, what Subodh suggested was that take a dictionary, okay? So what you do is you create a frequency hash table or a dictionary, and for each word in the file, increase its frequency in this hash table, okay? If it doesn't exist, you add it with the 1, and if it already exists, just increase the frequency by 1. And when no more words are left in the file, just print the hash table. Is this clear to all? Okay, let's take a look at the Python code. Python code looks like this. Okay, everyone. Word count equals empty hash table. This is where we created the dictionary. Okay, then we went to the file. Okay, we said file.read.split, and we went for word in this line. Okay, or we could also say for line in the file, and then we could split that line. And then we would say, if the word is not already existing in this dictionary, we increase its count by 0. We set its count to 0, and then we increase the count by 1. Got it? And once we are done with reading the file, what we do is we print the items. Are you clear? Everybody okay with this code?
yes,
Now, the question is, what is wrong with this thing? What are the limitations of it? This is accurate code. This is appropriate code, what we're looking for. But there is kind of limitations of this. There are limitations of this one.
Because of memory?
Correct. Correct. Where all is the memory? One is this dictionary is all in the memory. Correct? Second, file.read is reading everything into memory. This one we can avoid by reading line by line. So at least this will not load into memory. This we can avoid. But this one takes a lot of memory. This one takes a lot of memory. What will you do for this? The dictionary, if your data, here the data is fitting in the memory. Okay, this is 500 MB. Okay, this is 500 megabyte. This can fit in the memory. But if it is 10 gigabyte, 10 GB, okay, the dictionary might overflow. Okay, so the question is, how would you do it if the file is really, really big that can't fit in the memory? All right. Okay. So this was first approach. Any other approach you think? Anyone? Sameep's point is parallelize the workload and process small chunks. Okay. Let's look at your approach. Similar, yeah. So let's take a look at that approach. How would you do it? Okay. So we have a file containing, say, 10 GB. Okay. Now we broke it down into, say, 500 MB 20 files. Okay. Fine. From the top, as soon as we reached 500 megabyte, we created a separate file. Now we have 20 files, each of 500 megabyte. Okay. How would you, in the whole of 20 file, how would you find the unique words? Go ahead.
Splitting the file won't solve the problem, right? Even if you split the file, you will have to read all the word. The dictionary will again remain the same, right? It is list of distinct words.
Yes. Because dictionary requires everything at the single place, correct? It's like a singular tally in which you are keeping the counts.
Yep.
Okay. So yes, you are right. The dictionary, if you're using dictionary, then splitting the data will not really help. Can you think of any other approach?
Yes, so can we use this database like
Okay. Okay, go ahead. Give me an idea.
my key, my string as the key pair value and the add increase the value count. Like dictionary replaced by the database table.
Correct.
And the unique data we can constrain that this column as the unique name constraint will be the unique.
Correct. Correct. We can keep things in the database. Okay. Anything else? Any other idea? If your boss asks you to do it as a project, what will you do? Like practically. Database is a good idea. What else?
Like Redis also the same thing is also one type of database, so we can say this is the same thing.
Yeah.
I mean, one other brute force way is that, when you do 20 files, after each iteration of, say, one file, you write that in the DB. In the next iteration, read the earlier file, see if, you can update if the word is already there. If not, add the new word and rewrite the file. So you will not be keeping the dictionary in memory, but you will always write the dictionary back to a file or DB after every iteration.
Correct. So that is basically utilizing the database.
Yep.
Right? So the other way could be that you basically read the files using a Python program, create word and word one, or just one table with single column with called word. It has W1, W2, W3, W4 like that. And then you do a group by and do the count.
Yeah, this is also yes.
Right? So I think yeah, one is using the database, other is using your plain Python dictionary. What else? Good ideas, brilliant ideas. What else can you do?
Sandeep, can we try instead of the words replacing with the binary numbers?
Each word replacing with binary numbers. Tell me more.
So, in terms of the memory, it will be reduced if we use the numbers instead of the words.
Yeah.
I'm not sure
So,
how.
hmm. So that's a clever technique. That's a very clever technique. And that technique is used in the scenario where you can represent the words by a smaller set of numbers. Like, for example, phone numbers. We know the phone numbers only are 10-digit numbers, correct? They are not all the numbers from 0 to 10-digit numbers are not from like 0, 1. 0 is not a valid phone number. 1 is not a valid number. 1, 2, 3 is not a valid number. Therefore, for representing phone numbers, which are 10-digit numbers, you don't require normal number system. You can represent the phone number using a newer number system such that it takes lesser space. Okay, so that's a clever idea. But here, let's say that we don't have that luxury
Sandeep, one
because we
more
don't have
thing.
the specific.
Can we sort the word inside the file and the sorting based on the ASCII value and the suppose flag value is changed, then the previous count of the occurrence of the word we can count.
Good idea. Good idea. So you are saying, what if we convert these files? Very brilliant idea. So the idea is very simple. Idea is this, that what if we take the, okay, so brilliant ideas, very brilliant ideas. We talked about 4 ideas. One is representing the word using a different vector format. Okay, using a different number system, right? And the other was using, first one was the dictionary, then database, then using the vector format. And the last one is sorting. Now, let's say we take each file, or we take the whole file, and using this file, we create another file in which there is word 1, word 2, word 3, word 4, word 5. Like that, we have created big set of files. Got it? And then using one of the sorting algorithms, we sort it such that we get W1, W1, W2, W3, 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 W4. So all the words which are same, they will come together the moment we sort, right? So if we take the data, if we convert this into one word per line and we pass it to a sorting algorithm, we would be able to sort it, right? Now, this technique can be used very cleverly by creating 20 separate files. How? Let's say you sorted all the 20 files separately, correct? You sorted, say you basically created 20 separate files which could be overlapping, and then you can merge them together. Imagine there are 2 files. First file is W1, or let me just give it good names. Okay, so we call it, so the first file is apple, banana, cherry, and dog. Then second file is apple, apricot, berries, cherry, and dog, right? So you basically created multiple small files, 500 megabytes, and then you sorted each of the file. first file contains apple, this is small a, and so on. You can see these are common in both, and so on. So sorted files you can merge very neatly. Correct? Can you merge them? Can you write code to merge them? Two files? How would you merge them?
Use technique like, I mean, what we do in merge sort, right? We take one word at a time and see which one is smaller and then
Correct.
add it and then increase the counter.
Correct. Correct. So basically what you do is, just like, do you remember the prayer assembly time? If there are two queues of kids who are standing in their ascending order of their height, meaning sorted, similarly to the other queue also sorted by the height, what do? You stand in front of the queue and then you compare the person who is in the front and then put the smaller one in another file. Good? And once you're done with that, you have merged the entire file in a very, very, very small memory print. Okay, let me just walk you through this exercise. Okay, so the other technique, one was we talked about the memory one. The second technique was the SQL one. But in SQL, most of the heavy lifting of sorting and everything is being done by SQL. The other thing is using Unix pipeline. Those, even if you have not gone through Unix, I will just walk you through again here. So in Unix, every program takes input from you, correct? And prints output to you, okay? Like for example, when you type a command like ls, it prints the list of files on the screen, right? So let me just show you, okay? So like for example here, if you, let me go to this one. Okay. And yeah, I'll just open the terminal for now. All right. So if I say ls, it is printing the things to me. Okay. This is the list of my files. In your case, it could be empty. In my case, there are just too many files. Okay. So this is printing some output to me. Okay. It did not take any input from me. Now, instead of giving the output to you, you can pass it to another command. Okay. Like, for example, there is a command called wc. What it does is, whatever you type, it just counts the letters and words in it. So to end the input, we press Control D, and then it printed that there are 2 lines, 6 words, and 32 letters. Okay, so WC is basically doing the word count. Now, when we used the WC, it took the input from me and gave the output to me, right? We can pass the output of ls to WC. So it took WC, instead of taking the output from me, it took the output of ls and processed it. It is printing the number of characters, number of words, and number of lines. Okay? I hope you got the idea of the pipe. This is called the pipe, standing pipe. Okay? Now, you can create using you can create you can do the word count using the Unix command. Okay. I will just give you a brief about it. And what's happening here is we will take, Okay, we will take, let's say, here. Do you see here? There is just try to find. Okay. Yeah. So let's take a case of this particular file. Okay. And all right, it has got these many lines, these many words, these many characters, and so on. Okay. So I'll just copy this file from here to my home directory. Okay. So now I've got big.txt, a file. Okay. Let's take a look at few words from it using the command called head. Okay, head.big.txt will print you the first few lines of the file. You can see these are few lines from the file. Okay, the file itself is big. You can take a look at big.txt, 6.2 megabytes. Okay, now these are the few lines of the file. Now, what do we want to do? We want to, let's say, take this data. Instead of printing it on the screen, I'm passing it to a command called sed. Okay, and I'm substituting space. I'm substituting space with a new line. Okay, so these things like the came in one line. You can see here. The came in the project, Gutenberg, ebook, right? So what I did was we converted this line into one word per line. Okay. So what we are doing? We are replacing space with new line. Good. So head printed first 10 lines. Then SED took those lines, replaced space with new line. Okay. And then we did the sorting. You can see the moment we did the sorting, it brought together the words. You can see project came together, right? So the technique that he was saying, now afterwards, there is a command called unique, okay? And unique basically just counts the sorted data, okay? So we were able to do the word count. Now, instead of using head, I'm using another command called cat, which will print the whole file onto the screen. SCD will replace the space with new line. Sort will sort the lines, and the unique will count the sorted data. That's it. So done. This is third technique. Yeah, are you guys okay with what we're doing right now?
So Sandeep, this Unix command or something we are doing here, how to use the like Python program in between the Python program?
You can just type your Python code right here. Like if you want to use, say you created your own program. Okay, I'll just go to, what was that Python? This one, right? Let's say we wrote our own Python program. I'm just saying pick, right? Count sorted. Okay. And .py. Okay. And I'll just see read lines from std in Python. Okay. So you can simply say for, where is that thing? sys.std in, that's it. instead of anything, that's a file handle. So I can say import sys, and I can say for, okay, I'm going to say previous equals none, okay, for line in sys.stdin, okay, if line equals, I'll also keep a count, okay, if line equals previous, okay, just increase the count, okay, else count is reset to 1, okay, and in both the case, and then previous is also set to line. All right, the other thing we can do is we can do a print previous, okay, and
What is it doing, Sandeep? Sorry, I didn't get this.
I'm coding his approach, okay. I'll tell you what he's doing. So what we are trying to do is, if data is sorted, what we'll do is we'll just count the unique of it. Like if the data is, let's say, um, A, B, 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 C, D, like that. So we will start from here. Okay, data is sorted. We'll say keep increasing the count as long as the previous and next are identical, right? And the moment you get to another new one, you print this as A2, and then you start counting. And the moment you reach here, you print B3. And the moment you reach here, you print C1. And when you're done with everything, you print the last one. Okay? This is the code we are writing right now. So we have to convert A, B, 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 C, D to A2, B3, and
But
C1.
Sandeep, this input data A, B, B, C, we are reading from the some file, not reading for terminal, right? Like,
Right now, we are reading from the standard input. So we will pipe the data to the program, and it will behave as if it's going to reading from the file. Got it?
okay.
So we'll use this program like a filter. Okay. The data that is coming in the pipeline will be coming to this program as well. Okay.
Okay.
So what we are doing, we said import sys, previous is none, count is 0, line in sys dot, we are reading line by line from standard input. And then we are saying line equals previous. And then we are increase, if the line is same as the previous, we increase the count. Otherwise, we print whatever it is. Okay. Now, here there is a problem that in case it's the first line, it will print none here. So we can say if previous equals none, not equals none, then print. Okay. And then once we are done here, then again you print the count. Yeah, we print the count once we are done with the loop. Okay, what happened to this guy? Okay, so this should be outside the loop. All right, let's see if it works. Okay, let's see if it works. We are printing echo 1, new line, 2, new line, 3. What should we do? Should I? Okay, echo 1, 1, 1. Or let me just say A, B, 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 C, D. Okay, I'll just substitute the space, substitute space with new line. Yes, now it's good. Now I'm passing it to my program. What was the name of the program? Count something. Okay, so it did the job, right? It did the job. Just that there is extra new line that we can strip. Got it?
Yeah.
So we basically said echo printed A, B, B, C, C, D. Then we said echo followed by SED. It replaced space with new line. And then we called our program to do it. Okay. So our program started with previous and this, kept on increasing the count, and then kept on increasing the count of B, and then C and D. Right?
But that is not a real life scenario, right?
Why not?
Why we work on the some big project, then who one like give you input as the terminal or something like that? Someone.
No, see, this is more practical. You'll be amazed to know this. The entire map reduce, if your program is reading from a std in, you can feed it any data. Okay? You can feed it, like here also, we can now use this program as part of instead of unique, we can just say count, that's it. It will do the job. See that? It did the job.
Okay, yeah, that is. Yes.
Okay, so this is much more, reading from std in is much more practical way of doing it. And as a matter of fact, when I designed the big data systems long back, the recommendation, most of my map reduces were actually like this. Okay, most of my map reduces were actually like this. Okay, are you guys okay?
Yeah,
All right.
I am not
So
aware. Thank you. That.
okay, so if your idea was good, okay, that if we take the data, sort it, and then we can do the counting. Okay, so basically, first code that we wrote was the Python one. Second code we wrote was, sorry, first code involved the dictionary. Second code involved the sorting. So what we learned is that if we can sort the data out of this pipeline, right? Out of this pipeline, this is clear to you. Cat command reads file and prints onto the screen. SED command substitutes space with new line. This you can code, right? You can replace space with new line using Python code, right?
Right. Yeah.
What about sort? Okay. Can you code sort? We will talk about that soon. Okay. And once we have sorted it, we can do the counting. Correct? So many problems can be solved by using the sorting. Okay. Now, here, please pay attention. Which is the most time-consuming task? Which task has complexity bigger than order of n? Which task is going to be taking most CPU out of
Sorting.
cat, SED, sort, and count sorted?
Sorting.
Sorting, correct. Sorting is the highest time-consuming exercise out of this. Okay? All right. Is everybody okay?
I have a question regarding memory. How this 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 is better than dictionary?
Question, very, very valid question. Very valid question. I was waiting for this question. Here, the very important part. Okay. If this file, right, is really big, okay, is really big. So what you will do is you will create big one, big two, big three, like that, hundreds of files. You will do the sorting of all of those files separately. You will basically say big one underscore sorted dot txt. So you basically break the file into parts. You'll read some parts right? Splitting the file into parts will only consume storage. It won't consume the memory, right? It will consume only the storage and maybe time. So you'll read line by line, keep putting in the separate files. Now imagine you have created files like big1.txt, big2.txt, big3.txt. Like that, you have created 200 files. Okay. What you'll do is you will sort all of these 200 files separately. Okay. And now here's the beauty. There is a command called sort-m, which will basically merge these sorted files. And you have the entire sorted data. Now, the question so once you have the entire sorted data coming in, then your count sorted can basically deal with it very easily. Correct? Are we on the same page? Like, look at this code, right? Once our data is sorted, this code, what is the memory complexity of this code? Tell me. How much memory would it
It's
consume?
reading only one line, so it is not much. No.
It's a fixed one, right? So we call this order of
One.
Color should be black. Order of 1. Okay. So it would be order of 1, right? So it doesn't consume any memory. If you see, our word count program is not consuming a memory. It is time complexity. How much is the time complexity of this one? Order of n.
And depend on the
N.
Right? One loop, linear loop, keeps on going, order of n. So time complexity is order of n. Memory complexity is order of 1 because it's a fixed 2 variables, previous and count. That's all. This is a number and this is a text. Okay. So if our data gets sorted of our terabyte files, that is doable. Now, so we have a program that can sort small data in the memory. We have a program to count, that's all done. Now, how do we merge this big data? Right? We have so many of files. How would you merge sorted data? That is the question. Okay. How would you, right, merge sorted data? .py. Okay. So we have to write a function, okay, that basically merges sorted files. Okay. Right? How would you do it? Okay. Let's define a function called merge. Okay. It takes file 1 and file 2. Okay. And it basically reads line 1. Sorry. Let's go with array for now. Okay. Let's say you have two arrays, array 2 and array 1. Okay. Array 1. You want to merge them and they are already sorted. Okay. What will you do?
check the head of the both array if both
Okay. Check head of the both. Okay.
if both are common, then no transfer to the each other is the common place, and then like move to the second array and check the second half of the comparison of the first array of the head, if
Correct. Correct.
something like that.
Right. Right. So what you can do is, let's say we keep the pointer I equals 0, j equals 0. Okay. Who can dictate the code for me? Okay.
For I in array 1,
Okay. While I, okay, less than length of array 1 and j is also less than array 2. Okay. So both are, so we have two pointers, 1 being in array 1 and array 2. This can be visually seen here. Okay, this can be visually seen here. Let me just show you this part. So anyway, the approach we have been talking about is these ones I have already written down here. Okay, I'll just come back to the merge sort in a moment. So what we are trying to do is, right, we tried using the approach, Unix approach and SQL approach. The problem was that it can't go beyond RAM. Okay, it becomes a problem. What you will do is we'll basically use external sort, and what we'll do is we'll split the file to fit the size of the RAM, and then use any of the approaches to find frequency, and then use the merge sort, merge the sorted data using sort-m command, and sum up. So what we'll do, we have a machine 1, machine 2, right? Let's say machine 1 contains sa, re, and machine 2 contains ga, re, and then both of them gives us the sorted data, re, sa, and ga, re, and launcher will merge them. Now, merging the sorted data, okay, how would you merge? A common answer is just concatenate the two files and then use the sorting algorithm again. That will not help. That actually becomes much more slower. If you try sorting the sorted data, you will end up with a very bad scenario. Okay, more like that couple of algorithm actually perform really bad if you try to sort the sorted data. Okay, so now the question is, what's the point? If you are basically again merging all this data and sorting using the same command, what is the advantage? We are not taking the advantage of the fact that both the data sets are sorted, right? Instead, we will do this. Okay, imagine we have two arrays, array 1, array 2. In the array 1, the data is already sorted. This one is shortest, and this one is the tallest, and they're standing in the order of the increasing height. Similarly here, so what do? We compare the head, okay, and we find that this one is shorter. So we basically figure out from which queue did we pick this person. Okay, from the same queue, we will pick the next person now. Okay, so we basically put this in the output, and from the same queue from where this has been picked, we move the pointer to the next person. Now we compare this and this, and we pick the shorter one. We keep on repeating this exercise over and over until we are done. Okay, that's it. And whoever is left in the end, if there's nobody left in the other one, you basically append all of these in the outcome. Are you okay with this? This is clear, right?
Yes. Yep.
Okay. Now, let's take a look at how do we do it, okay? And let's go back here. Oh, where did it go? This is not required.
Files, it has to be number of parts it has to split into. Is it based
What?
on, let's say we have to decide the number of parts this file will need to be split into?
Yes.
Then say, do we simply look at the RAM and then we pick up the files based on the size that we can fit maximum?
Correct.
We keep minimum as long as we into the RAM.
When we are splitting, we decide at that point of time itself.
Yeah, at that time, how do we decide how many parts?
You know the memory size of the computer, right?
Okay, that's based on the RAM size.
Yes.
I to files, minimize the parts as long as we are able to fit into that.
Correct. Correct. Okay, let's take a look now. I'll just create a notebook because, okay, here. All right. Should I just take it from here? Okay. And we go here. All right. Who can help me? All right. Now, so we are saying while I is less than length of array 1, okay, and j is less than length of array 2, okay, if array 1 array 1 ith element equals array 2 ith element, okay, or let's just do this way, okay, we will just pick one, okay, if array 1 ith element is less than array 2 jth element, okay, now ith element in the array 1, the head, right, the first element is lesser, so the result, let's keep the result like this, we'll say result dot append array 1 I, okay, and then we increase I, okay, otherwise what do? We increase, we basically in the result we put j, okay, make sense? Okay,
2G.
One condition
Line,
is missing.
what?
line 11. In line
What?
11, we need array 2.
Array 2, right?
Array 2.
Also,
Okay.
the equal condition is missing.
Do we need it?
Equal I equal to j. If array of I equal to array of
I'm saying that do we need that?
It comes
I
with
think
else.
no. Yeah.
It
No.
can be handled, right?
Yeah, it can be. Yes.
Okay. All right. And once the loop is over, we'll say if I is less than array 1, meaning there are some elements left from left in the array 1. What do? We do the result dot append, okay, and result dot append or result dot extend, or how should we go? We can just say for, okay, while, or we can just put it like this, okay, while I less than length of array, we'll say result dot append, okay, and we'll just say array 1 I and increase that by 1, and similarly we can do this. This can be optimized a bit, okay. All right, I'm just checking if anything is left.
Sandeep, can we use slicing and change the while to if condition and just
Which one?
while I less than, instead of while I less than length of array 1, we can use if I less than length of array 1 and result dot append of array 1 and use slicing. So
But then it will append the whole array as a single element.
But when we use slicing, can we use slicing?
We can do this. We can do extend. Okay, we can say if I is less than this, and we can do this. Yeah.
Okay.
You got it?
Yeah, good.
All right, that's my method. So let's take a look at, can it actually do the job? Okay, it's going to merge them. Okay, and it did not return the result. Okay, did it work? All right. Would you be able to code it in the interview? Just say yes. At least.
Yes,
Okay.
yes.
Okay.
I mean, the same problem obviously is.
Okay. No, I think this is a very important algorithm. Okay. People will not ask you to code the sorting algorithm, but they will ask you to code this part. Now, question is, if the size of array 1 is n and the size of array 2 is m, how long will it take? What is the complexity of this one?
Order of m plus n.
Order of
M plus n.
m plus n. Anybody else?
M into n.
How m into n?
Order of n.
M into n. I read this.
Where?
I don't remember.
It is the order of the max of m and n.
Max.
Neither
Yep.
m plus n nor m into n. Okay? It'll be max, right? Because first this loop will go up to the minimum number, and then one of these loops will go for the remaining elements. Correct?
Yep. Yeah. And Sandeep, you mentioned like when we are saying m plus n, I remember in one of those complexity classes, you mentioned, I mean, m plus n is again order of n, like, whatever is bigger.
This is an order of n. It's an easier way to say that it's an order of n. And other question is, what is the memory complexity? Order of m plus n, correct?
Yep.
Okay. Everyone okay with this? But it's completely okay to say order of m plus n as well, because there are operations that are happening in this. Okay. So in simple words, you can just say that it's order of m plus n, because for every, like both the elements that the thing is happening. So whether it's m plus n or max of m or n, it's basically order of n. Okay. It's a linear algorithm, and it doesn't, right now it is keeping this result. Okay. But if we have two files which are sorted and we have to write the data into third file, that we can essentially do it in the same way, right? Without consuming any memory. Okay. So we can basically say, right, this is, let's say, file 1, file 2. Okay. And we are here opening both the file. Okay. And this is the, or let's just call the F3 file. Okay. We will assume that people give us these three handles. This is the input file 1. This is input file 1 handle. This is input file 2. And this is output file, right? So we can here say, okay, we can simply say, right, I equals to 0 and so on. Okay. And here, all right. Okay. Now, we basically read line. Who can help me code this? We are reading the data from two files and writing it into the output file. Okay. Same algorithm. Instead of memory, we have to do it in the file. Tell me.
Like first open the file.
Okay.
Both file we are open.
Okay.
And check that file is empty or not.
Okay.
And then by the read method, we read the all data from the file and the.
Okay. So let's do this. Okay, we'll write an infinite loop. Okay, we are reading line 1.
By the read line.
If I input file, okay, and let's say from the beginning itself, we are reading line 1 from input file dot read line 2 input file to read line. Okay, we read each line from them. Okay, while line 1 and length of line 1
Read
length of line 1 greater than 0 and length of line 2 greater than 0. Okay, the moment read line fails, it will return the empty line. Okay, now, okay, so we are basically just doing this. Now we are saying keep doing this until line 1 and line 2 are not empty. Okay, now we check that if line 1 is less than line 2.
And Sandeep,
Okay,
if we are reading the all lines, then read lines आएगा, S आएगा.
नहीं हम एक line पर, we are just doing the single line.
Okay, okay,
Okay, we are reading one line at a time. Okay,
okay.
now we are saying if line 1 is less than line 2, okay, what do? We put in the output file, we write
Right.
line 1, okay, and then we say line 1
Again,
equals
read line.
input file this read line. Okay,
Yeah.
else output file
Line 2.
dot write line 2 and line 2 equals, it's a very, very important algorithm to pay attention. Okay, that's it. Okay, and
Indeed,
basically
the input file 1 and input file 2 are the sorted files.
File handles. Yeah.
And they contain sorted words.
Correct. So we basically splitted the data into smaller parts and kept them in like hundreds of files, and we are merging 2 at a time and then repeating the process.
Got it.
Okay. So now here is right, and then once we are done with that, we can say if so we right, one of them will be empty. Okay, if okay, there could be a scenario where length of line 1 equals to 0 or length of line 2 equals to 0. Okay, and okay, remaining file, okay, we will say if length of line 1 equals to 0, then remaining file is equal to this one. Okay, and then else remaining file is this, right? And then we say same thing for line in remaining underscore file. Okay, we'll just do this. Make sense?
Isn't it? Go ahead.
Line number 13 dot f1 dot read lines आएगा कि just like cursor written the all lines in the remaining file.
No, we are reading one line.
Line number 14, like you just simply remaining file equal to the object.
I don't want to. The important part to notice here is I do not want to read more than one line at a time. Why? Because the file could be very big. And I want to, I'm being very cautious. So tell me, how much memory does this program consume?
So before we go in there, right? Something one question on line number 14 or line number 16, right? The
Yeah.
I have if I have one or I have two, right? That's a pointer, right?
Yes.
What does that what does that do? Is it if you do this, will it append the remaining file to
No, it won't.
the remaining
It won't.
file?
No.
What does that line
Remaining
does?
file will become a file handle. Remaining file is a file handle now. Instead of basically, this will become a file handle. This will either be IF1 or IF2. It'll be another file handle. Basically, whatever file handle is left, that one is. Oh, okay, sorry. It should be the opposite. It should. If length of line 1 is 0, that means line 1 is done. Okay. It should be. I'll just make it. I'm saying if any of them is left, there could be a scenario that both of them are done. So we don't need to come in this logic, right? And this is better. If length of line 1 is not equal to 0, we do this. Otherwise, we do this. And that's about it. Okay. And we can actually just try it out. Should we try it out?
Yes.
Okay. Let me try.
Sorry, we don't need line number 12 at all, right? I mean, after the while loop, once we go out of the while loop, right? We will check if length of line 1 is not equal to 0 and then do it, right? We don't need line number 12. Or else we can just put if condition on line number 15 to check if line 2 is there.
You are right. We don't need it. We don't need this logic. We can basically, because anyway, it will stop somewhere, right?
Yes.
Okay.
No, we will have to check, right? If I have 2 also ends, both can also end, right?
Yeah, that's what basically that's what I'm checking. So if length of line 1 is not equal to 0, that means remaining file is IF1, otherwise IF2. Okay.
No, but
and then, let's say this has ended. Okay, this has ended. So this loop will anyway not run.
Oh, okay. Got it.
Yeah. All right. So what I'm trying to do here is a very, very important thing. Okay. So I'm being very cautious with memory. Okay. How much memory is it consuming? Only one line. Isn't it? Just 2 lines actually, right? And nothing else. That's what it's keeping in the memory, right? So let's try to do this experiment. Okay. I know that you may not have done this kind of thing because usually there is a framework. Okay. All right. We'll call it file1.txt. And in this 1, 1, 1, 2, 2, 3, 4, 5, and 10. Not 10. Let's say 9. I'll tell you why. Because this will do only the lexical sorting. It will not do the non-lexical sorting. So file 1 is done. Let's create file 2. Okay. File 2, 1, 1, 2, 2, 3, 8, 8, and then 7. Okay. So these are the 2 files we have. One is file 1, file 2, file 2. Okay. Now, file 1, file 2. We have created 2 files. Remove this new line from here. Will it work? Yeah. All right. Let's just do that. Okay. Now let's go back to our notebook. today's date is July 7. Okay, now we are saying input file 1 equals open file1.txt. Okay. It was like this only, right? Okay. And then I am saying file3.txt. Okay. Now, what we are trying to do, we are calling this file merge sorted file. Will it work? Let's see. I'm going to take a look at the file. Okay. So it has done the job. Let's further examine file1.txt, file2.txt. Okay. So file1 contains 111 3 times, and file2 contains from here till the end.
9 is
right?
also.
It didn't printed 9.
Where? Oh, we did
9.
not print.
The remaining part. It didn't work.
You know the reason? Because it doesn't have a new line after 9.
Okay.
Okay. So that thing is troublesome. Okay. But why did it not print 9? That's what I'm wondering. Would it not read the line which contains the thing? Okay. All right.
No, you'll have to run.
I'll just
Run
delete.
again.
Yeah, I'll just delete this. Okay. Good. So there is a bug in our code. Where did my 9 go? Okay. So 9 did not. 5 came, right? 5 came. So 1, 1, 1, 1, 1. How many ones? 5 ones. Then 2, 2, 2, 2. 4 twos. 4, 1, 2, 3, 4, 4 twos. That's correct. And then there is a 3, 3, and 3. Okay. 2 threes. 1, 4. Right. And then 5, 1, 5. And then 7, 8, 8. 5 is done, right? 5 is done.
Yeah.
Now 7, 8, 8, correct? And then 9 it did not do. Any idea? So
I think the issue is from 12 to
16.
16.
Yeah. So what has happened is that, okay, so the second file kept on going, okay. So what happened was that up to 5, it matched, then the second file, it kept on reading, and basically we read, okay. 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 Should we do this? We'll just take a look at the read line function. Okay. We'll just say input.
Sandeep, in our loop, we were storing the line 9.
Okay.
9, and we are not printing it, but we are skipping it. If you go.
Where?
So when we are doing while loop, we are reading line 1 and line 2 both,
Oh,
But
last one, right? Line. Okay. Yes,
so
yes, yes. So the last one that is left, right, is something that we are not doing correctly. Okay. Okay. We will just say, is that okay? Okay. So we are saying while length of line greater than 0. But again, the same trouble will happen here. Okay. Same trouble will happen. We can do this. Instead of going this route, we can do this. Okay. We can basically just print here, isn't it? We can just say here. Okay, like this. You are so right. Thank you so much for debugging that issue for me. Yes. All right, it has done something. Let's just delete it and then do it again. Okay. Yeah. So it has done it. So after 788, it has printed 9. Okay. The only problem is that it did not notice the new line. Like if we put the new line there, then it'll be okay. All right. So we can try again. I'll just delete this file. Good. All right, let's just try. Okay, yes, this time it works. All right. Now, do you see that this is good, everyone?
But I think in last for loop we are writing OF dot write line. Then why we are writing OF dot write line 1 or line 2 in if or else condition?
Here, right? See, actually, we are just wasting what we read here. So only one of them is empty. The other one is still lying around, and we have not written it to the output, correct? The 9 was missing because of this reason. We
But
read
we
it.
are putting it in remaining file and we are then writing in.
Yeah, but remaining file doesn't contain the line 2. Line 2 has already been read. Got it? The line 2, we read it, but then we started reading from whatever is left. But these variables, this thing never got written to the output file. Because
So
when this loop ended, only one of them was empty. The other one was not. Okay. And therefore, that variable is just gone waste. It
so
is
if
not.
we comment that last for loop, I think even if that will work, if we comment that last for loop.
No, it won't work if we have one more 9. What correct me Sandeep if my understanding is wrong. What we did with 12 to 17 is that we added only the first 9 which we read, and then from 18 it is the remaining of the file. So if we had more 9s after that, it would get printed only after 18, right?
Right. Okay. Am I making sense? No? Yes. Okay. If I comment it out, we can actually test it out. Okay. We can
Or just
essentially.
we can add 2-3 more numbers through any of the one file.
Yeah. Let's say, okay, this is my file 2. What would you like? And this is my file 1. Okay. So file 1 has 9 here extra, and this one has 788. Okay. Now I'm commenting this piece of code. Okay. I'm commenting this one, right? That's what you want to comment. Correct? And
Yeah.
all right. Did it work?
It makes the last name.
7889.
Did we add 2 lines?
Wait, why did it work? It should not work.
Remove number
No,
9 from text
we
one.
need to add 2 lines. We need to add 2 lines in file 1.
Let's just say. Okay. All right. But okay, I also did not delete the file. All right, I'll just delete the file. Rn doesn't get truncate by itself. Okay, let's just start. Yeah, you can see
Only 1 line.
only one line. Because what happened was it compared and the other file ended. See, this one had 8 records and this one has 10 records. Okay. The moment that thing ended, it basically just stopped there. Okay. And remaining thing is still lying around in that file. So it basically kept on comparing. And when it reached 9, it basically just printed this. And this 9 also was written because of this particular logic here, this logic. Okay. And then this 9 was left in the file. Got it? If there is more data in one file, let's say, right? Let's see. Okay. So then again, that remaining of that will never reach. Correct? You see, it is stopped at 9. Basically, the moment the first file ended, the program ended, the remaining things did never, right? If you see this logic here, what it is doing, while any of them, as long as both the file are not ending, both files are good, this loop runs. Okay. The moment one of the file ended, this loop exits. Because the read line will return empty. So line 1 will become empty, or line 2 will become empty. Okay. If both the files have equal number of lines, okay, or both the files are such that basically till the end they are both going parallelly, equally, then this is okay.
Can
Like
you
in
uncomment it and run once more?
now see, okay, now it has come. So these 3 lines that were missed out are being printed here. Okay. You see that? Is everybody okay with this logic? Right. These are very valid questions, and I'm actually super happy with this particular class that most of you are, able to come up with ideas. Yeah, go ahead. Uh, who was the person who asked just now? I'm waiting for you. Okay, so I think it was a mistake. Now, is everybody okay with this logic, or do you have doubts for me? Feel free to say.
So what is the memory complexity for this?
Yes, that's a question that I am supposed to ask and you are supposed to answer. How many variables, how much data we have loaded in the memory? One is this variable, other is this variable, other is this variable, and then this variable, and this variable. And I think that's pretty, and one more. So I think these are independent of, the
Size
input
of the
data
file.
size. Yeah. And therefore it's a order of one. That's the memory complexity. Okay. And the time complexity is order of. Okay. The only thing is that it's reading two files simultaneously and writing third file. If the operating system doesn't allow reading concurrent files, then it won't work. Otherwise, it will work fine. All right? Are you guys okay with what I'm doing here?
Yep.
I think in this case, the time complexity is order of n. But in addition to that, the IO cost, the time spent in IO will also be higher, right?
Yeah. IO cost will be higher. That's correct. But that again is an order of n. Perfect. Now, moving on. So we just wrote the merging logic. Everybody is okay with merging logic?
Yep.
Okay. All right. All right. Let's see if we can do this. Okay. There will be some of the clever code coming up such that here in this particular logic, the result, we are storing extra data in the results, right? Extra storage in the results. Okay. Can we minimize it? Okay. Okay. That's we will talk about that later. And
So, sorry, can you repeat that? What extra are we storing in result?
okay. Here, if you notice that result, we are having this extra storage, correct? If somebody asks
Oh,
you
okay. Okay,
that,
in place. Okay.
yes, yes. Okay. So here is a question that I want everybody to think about. Okay. Question is, it's called a flag question. Okay. Question is that there is a list, okay, containing zeros and ones in random order. Okay. Now move all zeros to one side and all ones to another side. Okay. How would you do it?
No, with sorting is nothing, right? You have to sort it. You have to sort it, right?
Just have to, move it. Yes.
Do you want to create a new list?
We don't, yeah, good question. Without using another list. Yes.
Via Python, we replace the indexing of the zero. If the value of the any index is zero, we like the append to the last, like
Yeah.
pop from the their particular index and the insert to the last index of the list.
Okay.
Like first index we pop the zero value and the insert to the last index of the list. So every time
Okay.
when like when we reach the like
Okay. So, but you are modifying the length of the list, correct?
at the end is the
No,
same. At the end is the same. We pop and insert.
Okay. No, when you
I mean,
pop,
why can't we use merge sort here? Like divide the array into half, like sort, and then start going back all the again merging it together. So that would be like um, 0 in the beginnings and 1 at the ends.
Okay. Think about it. How would you manage it? Because let's say we are keeping 2 pointers, one from the middle, other from the beginning, right? 2 pointers. And
I
we're
mean, I'm
comparing.
talking about splitting the array into 2 parts, like, N1 and N2, let's say. And I mean, half of the element goes into the, temporary first array, half of the array go into the second, and then you run the, merge sort, like start breaking it up to the very last, and then you start swapping it over all the way back, and then like
So
similarly, like
you're talking about sorting it, right?
yeah.
So we could just in place sort it, correct? That's what you're saying.
Yep.
Basically, so here's a constraint, very, very clear. This data only contains zeros and ones, okay? And we basically have to just sort it, okay? And without using any extra memory.
Oh, okay.
Okay.
Sandeep, the solution which was suggested just before, right? The pop and the insert, right? That will change the length of the list by only one element, but that will also, I mean, but that will work, right?
Okay, let's see how it works. So you are saying pick this, okay? No. So the question is, let's say it's 0, you don't pop it. But if it's
Yep.
1, you pop it. Okay. And
Yeah,
then
you add it in the end and then pop that one.
And then basically every time you remove this one element from here, all these elements will be shifted to left.
Yeah.
Yeah.
That means the order is not order of n.
So there's like, since there are only zeros and ones, we can do one thing. We can go through the array.
Okay.
When we get to 1, we'll just record that index and we'll again continue and find the 0. When the 0 occurs, we decrement the 1 by, we decrement 1 to 0 and add 1 to the 0.
Okay. So are you saying, okay.
It's
now,
indirectly like shifting.
okay. Yeah. So basically you are saying that we could just count how many ones are there. Okay. And then go from left to right and keep writing 0 there, and remaining we can write 1. Correct?
No.
We are not
I don't think
counting
you said that.
once. Like I will once, like in the example here in the question, first we'll reach to index 2, that where 1 is there. I'm going to hold that index 2, and then the next time a 0 occurs, I will make that 1 into 0 and convert the 0 into 1.
Okay.
And then go to the next index. If there is 1, I'll record that index and I'll go on until I find 0. If I find a 0, I'll convert this
So what you're saying is you swap these values?
Yeah.
Okay. And
So
now?
Can we just count the
Then
number
again
of
we
zeros in the list and like
Okay.
iterate through the list once again and just replace the first like n
Yeah.
elements
Yeah.
with
Here is a trick. Okay. That's a thing that I want to avoid. So you can think of each zero is having some data. Okay. Some data. Okay. Each zero is also having some data with it. Okay. So that you can't really count and do the rest. You have to basically move them together. Okay.
so so Sandeep, we can if you want to do in place changes, right? We can start a pointer from the starting and one pointer from the end. The first one which comes in from the starting pointer and the first zero which comes in from the last pointer, we swap the values and then we
Okay.
move on
So
accordingly.
you are saying that we'll have two pointers, one from the
Yeah.
beginning and one from the end. If
Yes.
on the right hand side you notice that it is a 1 and on the left hand side it's a 0, you swap them, correct?
Yes. And then, yes, we swap them and then move ahead from that point till we reach the middle or till we reach where both pointers are pointing to the same element.
Or they are over. They have either
They are,
become the
yeah,
same.
yes.
Very good, very good. That's the approach that I am expecting. So
Oh,
would you
it was
like to
right.
code?
Okay.
Yes,
Sandeep,
that's right.
can't we take the sum? First, we can take the length and then we can take the
No,
sum.
no, I think see, very important part here is it's called a stable sort. A stable sort means that the data that remains with the value should also be there. So this 0 is the key, but there's a value associated with it. You can't just all zeros are not equal. This zero, and this 0 are not equal. Okay, this 0 has some appendages along with it. Like there is a data. This 0 has some data. Okay, so you can't really um uh you know just say that, okay, I'll count zeros and that's it. Okay, what I'm expecting here is that what I'm expecting is that here, that let's say this is 0, this is 0, this is 0. Okay, let me just change it to 1. Okay, so I'm expecting that this value would come up. Okay, this value would move here. Okay, as in all zeros will go to one side. Yeah, all right, let me. All right, so because the simple solution I was waiting for was that just count all the ones, put all the those many ones on the right hand side, put those many zeros on the left hand side, and that's about it. Okay, so I mean that you can set it quickly, but here I'm expecting that you can't just do that. You have to move the data. You have to move the data. The 0 also contains some data with it. Okay, so you have to move, you have to do the sorting instead of just flipping the ones. Okay, and this is a real problem. So you have data, you have only the keys with zeros and ones. And what you want to do is you want to segregate, you want to put them into like two ends of the same array without needing another array. Okay, so what I'm expecting out of it is that when you notice that there is 0, so this and this. Okay. All right. this is the expected outcome. Okay, there could be different order. I am okay if this 1 comma 12 comes here, okay, and this thing comes somewhere. As long as all ones are on the right hand side and all zeros are on left hand side, I'm okay. The order between the zeros could be anything, but the data should remain as is. Got it? I hope the problem is clear to everyone. Is the problem clear? No.
Yes, indeed.
Yep.
Yes.
Who said in the beginning? Okay.
I got it, Sandeep.
Okay.
Sandeep, what kind of sort is this you said? Stable.
Stable. We call that stable because we want those values to be at the same place. It should not just disappear. Okay. The other one that somebody said that, we'll just count the ones and put it on the one side, that's called counting sort. Okay. Counting sort is okay if you don't have values associated with the data. Okay. Like counting sort is good where, let's say, right? Let's say somebody asks you a question, sort the data sort the numbers containing the age of people. There are billion numbers. Okay, what would you do? Right? So this is an exercise. I want you guys to do this one. And I'm just taking an example, a bit different example where there's a list of numbers that contains the age of people and you want to sort that data. What would you do?
This also is in place sort.
Yeah, you have to sort it like, most efficient way. Okay.
Isn't the expected output not stable because the order of the equal values are changing?
Yeah, that's a very important question. So in an interview, let's say somebody is asking you that, hey, can you sort this data? You ask like, what kind of data is this? Then the person says, it's a data that contains age of people, only the numbers. So you ask like, is it going to be stable? Like if I just, count that how many people are in each age, let's say I maintain an array of 200 numbers. Okay. 0th index is for people with 0 years of age, and 200th element contains count of people with 200 age. Okay. So I can just go through this list of numbers, right? These billions of numbers, count how many people are in each age, and then I counted that, and then I go back and update the sequence and just basically print the data from the counts, right? Print all the people, how many people are there of 0 age, 1 age, 2 age, and that's it. Got it? So this is usually called counting sort. Okay. Okay. All right. So there are quite a few techniques you should in the interview or in any problem solving, even when you are talking to your friend and he's struggling with sorting the data, then you basically ask all kinds of questions. Like, what's your memory constraints? How big is your data? What does your data looks like? how much time do you have for sorting this, and so on. And why do you need sorting in the first place? Okay. All right. Now, so this question is, if this is clear, you guys should try solving it. This is a very important question, right? Because once you do this in place, okay, then you'll be able to do other harder questions. Okay. Is it clear to all? Yeah.
So should we provide a stable sort or anything?
Basically, make sure that you don't miss out on the data. The data should remain there. As long as, I mean, stable sort has a different meaning altogether. We'll talk about that later. So stable sort would be a wrong word here. And stable sort means that the element which came first should remain first, and so on. Okay. Here we are saying, let's say stable sort. Let me see what is the stability in.
So in that example, I think the one followed
Yeah.
by the value 12 should be the first.
Yeah, basically it's stable sort. Yeah, stability of a sorting, okay, is the if there are two values, okay, which, I mean, the values that came first should remain in that order. Okay. Basically, if there are two situations where word 1, word 2, if they are still, you know, even after sorting, if there's a confusion that, okay, they can be both, you know, they can be both orders, then choose the one where it's the same. Okay. How should I give you a good example here? So stable sorting is whatever was a sequence of objects which were existing in the input, that same sequence should be preferred in the output. Okay. And of course, it would need to be sorted. All right. So that's stable. But here, the way I'm saying is that you should not do the counting sort because the actual 0 contains the data. So you can't really do the counting sort. Okay. So solve this problem. Okay. And then use the same technique for doing it for 0, 1, 2. For 3 values. Here it's only for 0 and 1. And then you extend the problem to 0, 1, 2 by first calling this function with separating 0 and 1 or 2. And then second logic for separating 1 and 2. Okay. You should not use any extra memory. You should do it in place. Is everybody okay with the problem? All right. Okay. Now, so this is a brief about, you know, the things around sorting. Things around sortings are there are many things that are going on. Right now we coded merge sort. Let's move on with the, okay. All right. Yeah. So let's talk about the merge sort briefly. Okay. Merge sort. So merge sort is the main algorithm that people use for sorting the data, usually. Though there are insertion sort, there are bubble sort, you should take a look at the animation of each of them. Okay. So merge sort. Okay. What we did with two lists here, right? We merged two lists, correct? There were list 1 and list 2, and we basically were able to merge them, correct? Now, given a big list, if you keep on dividing them into two halves and do this process recursively, you should be able to sort the data. Okay, like for example, if I have, let's say I'm defining here, this is my okay, my merge sort, okay, and this is my array to be sorted, okay. And what I did was I did a very simple thing. I went to the mid value, okay. Mid value is, okay. First of all, I checked if length of array equals 1, okay, then don't do anything, return. All right. Okay. If it is length of 1 or 0, don't do anything, just return, or you can just return the array itself. Okay. So array of the size 0 or 1 is sorted in itself, correct? Then what you do is you basically divide. If it is more than 1, what do? You divide it into 2 arrays. You'll pick the middle point. Okay. How would you pick the middle point? 0. So you'll say length of array divide by 2. Okay. And then left is equal to array up to the mid. Okay. And right is equal to array mid colon. Okay. And then we use the merge sorted. Okay. And we return the result. That's it.
It should be integer division, right?
What?
Integer division, it should be 2 slash.
Yes. Okay. Let's see. Would it work? Would it work? Let's see. I'm saying 1, 2, 3, 5, and let's just put -3 and 9, 1, 2, 7. Okay. It did not sort it. Okay. So why? Because we did not call it on left and right. We should call the same function on left. Okay. Left and right. And that's it. Okay. Did it make sense to you? This is the most efficient algorithm that is used. When you say Python list.sort, this is what's happening. Is it clear, everyone?
Yep, more simpler, most easier. Yeah. I mean,
So,
it's running with very simpler complexity. You're just dividing the arrays into the smaller chunk and keep recursively calling them. And
yes.
sorting would be here automatically.
Yes. Is everybody okay with this?
Why we did it, I didn't understand.
We coded our own sorting algorithm. This algorithm is called as merge sort, and this is probably the most used sorting algorithm. There is another equally efficient algorithm called quicksort. We'll talk about that later. Okay.
I think his question is why we called it for left and right. Is that?
Yes.
I got that question.
Okay.
Because we have to divide it, each left has to be divided again until we reach one element. That is why I'm calling it.
Yes. Yes. So what's happening here is that we basically starting with this. Okay, let's start from here. Okay, let's start from here. Okay, we have, okay, just give me a moment. I'll move to the new page. Yeah. And So we're starting from here. Okay. All right. So, and then what we did was how much is the length? 3, 3, 3. 9 is the length. 9 by 2 is how much? 9 by 2 is how much? 4. So 0, 1, 2, 3. Not 4. Yeah. So it will basically split it up to here, right? Okay. So left hand side goes like this, and right hand side goes like this. Good. So we split it into this and this, and then call the same function again. That same function again is splitted it into left and right. Okay. And this is how it would split it. Good. Okay. So 1, 2, and this bracket you can ignore, right? Is there a way I can edit this? I don't think I can edit it. Okay, never mind. All right. Here, this will be divided into two lists. 9, 1 and 2, 7, 2, right? 3 plus 2 is 5. 5 by 2 is how much? 5 by 2 is 2. 0, 1, 2. So up to this value. And then this will be divided into 1 and 2, right? And then when we merge these two lists, we will get 1, 2, right? 1, 2. And then here, similarly, this will be solved in a similar manner. We'll have -3 and 5, and that will result in -3, 5. And then when it goes back, it will be merged using the merge sort algorithm, these two things. So this will become -3, merge it, 1, 2, and 5. Similarly, on the right hand side, and it'll keep on going back like that. Right? Good. Make sense to everyone? No?
Yes, Sandeep.
Yes, Sandeep.
Okay. So you can take a look at the merge sort animation. That will give you a good perspective. Where is that? This guy, I remember this guy. This guy. Okay. Say for here, example. Good. All right. So we started with using the merging the sorted array for a different purpose. That if you have big data and you have sorted the data individually in small files, you can merge them using the merge sorted, right? And then we use the same technique for creating the sorting function. I think this is clear to everyone. Now, question to all is very open question. What is the complexity of merge sort? Yeah.
N log n.
The order of n?
Order of?
N.
N log n.
N log n.
How did you come up with n log n?
First we are splitting it, and then we are again merging it. So that is why.
So the height of the tree that's going to be created is log of n. Correct? Because every time we're making it half, right? So how many times that it will go is log of n. Correct? So the height is log n, and width and everything is going to be, total is going to be n. Okay? And therefore, it's n log n. Okay? Everyone? So think about it, go over this and work out these examples. I'll be committing this code. I know that this is too much for today, but Deepak, you want to say something?
No, sorry. I was talking
Okay.
to someone. Sorry.
All right.
But I have a question, Sandeep, a completely different question. So is there a place where all the assignments or exercises that have been given since the beginning are there at one place?
For this, the one that I'm giving the class, no, I have been not able to do that centrally. But if somebody can help me doing that, it'll be great.
Okay. So basically then we have to go through individual lectures and check out all the questions or the exercises given, right?
And I want to give you one more exercise here. Okay. There are a couple of exercises I want to actually see. This is the real thing. Okay. And here is I'm sharing my paper. Okay. I'm sharing with all of you this question paper. Okay. And it's from my real life example. Okay.
You can't see any screen, Sandeep.
Oh, sorry. Okay. Let me share the screen. I'll be putting this in the repository. Okay. So
Yep.
here is the paper. Okay. This is from a real world problem. Okay. Real world problem is there is a recommendation engine that we have already, perfect recommendation engine library, which takes the data in the format user ID, product ID, score, and it gives the recommendation. The only downside problem is our user ID is email address. Okay. And this recommender wants this to be a number. So can you design this encoder and decoder? Okay. Keep in mind, if you're going to use hash code, there will be collisions. So you cannot really use the hash code for converting the email ID into this. Okay. So design the encoder and decoder using your technique. And then think about how would you deal with the data if this file is of, say, 20 gigabyte. Okay. That you can't do it in the hash map. Okay, so this is the problem I'm adding to the course, this one. All right.
And the ID should only be numerical only, right? Not
ID has to be
code.
number. It has to be long.
Okay.
Okay, it has to be an integer. Okay, so yes, and that's about it. I will commit the code.
Sandeep, can we use database for this encoder decode or only Python code?
You can use database, yeah. Okay. Okay, but my question would be that, is that really needed? Okay, let's say we don't use database right now. Just do it using Python code. Okay.
Okay.
All right. I'll just commit these files. Okay. Wait, what else? Count sorted. Is that it? Okay. Good. All right. Thank you, everyone, for.
So, yeah. So, Sandeep's like for all the exercises, we have to go through all the notebooks for each lecture, right? And then find out the questions or exercises from there, correct?
Yeah, that's what is the trouble. If somebody can create a Google Doc or something, I can create a Google Doc, right? And then you can. Okay. I'll just get it. Okay. And share.
You can
And
actually keep it in the Git repository itself, right? So
Yeah, we will add all questions day by day.
that's better, right? That's better. I think
Yes.
I'll just I'll just here I will create a simple text file. Okay, we'll call it exercise. This is way better, right? Okay. Okay, and we'll keep on committing the questions from it. Where is my yeah, this is way more easier. We are unnecessarily worrying about it. Okay, I'll just put this here. This is way more easier. All right. How do I?
Or maybe we can write a Python program to open every notebook and then find questions in case.
All right. Or maybe we can ask ChatGPT by giving the notebook that can you extract the exercises.
If all comment line we extracted, we have all questions.
Okay.
Yep.
Also, like recordings, everyday recordings, is there any specific link or page from where we can get all these recordings?
I mean, I think that is already there, right?
I'm not sure. I never checked it. So,
Okay.
can you share, Deepak?
Yeah,
No,
sure. Yeah,
no, my course is the recordings are there, right?
yeah,
yeah, exactly. Yeah, I think she is asking for that link, so we will share it on the group.
Okay. And
also Python is almost done, right? So now you can share the presentation so that we can go through once.
yeah. Check. It's there in the LMS. Everything is there. All the Python things. Okay.
Okay.
Check the
In the
problem.
course, a lot of lectures are there, but I'm not sure if that Python tutorial is there.
Actually, it's in the second section. The second, my courses. Then you can see.
Okay. Let's see if how it looks. I'm just committing this right away. Okay. This is one. Okay. And I'll just open my terminal. Okay. That's it. Cool. And
Okay.
I think somebody can help me just putting everything into this notebook, and then does it look good on GitHub? Okay, yeah, you can just copy this. I think it requires 3 lines so that it can separate them. Okay. Okay.
Sandeep, I also
Yeah.
have doubt regarding the encoder decoder question.
Yeah.
When we give input as email as input, then we can store it as any number, or is there any particular order?
It can be any number as long as Sandeep at Gmail. If you encode it as 1, 2, 3, and it occurs again, Sandeep at Gmail, it should again become 1, 2, 3.
Okay. So when we and in the decoder, when we give us 1, 2, 3, it should give us Sandeep at Gmail.
Yes.
Okay.
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 Good, everyone? All right. Thank you, everyone. Have a good day.
Thanks, Sandeep.
Thanks, Sandeep.